to machine learning. First is pattern recognition. So in pattern recognition, it is mostly you are recognizing the pattern as I discussed in the video streaming example. We are trying to recognize the pattern within the data and the relationship between these patterns. What is the relationship between short-term and long-term patterns? Does this have a relationship between these two? Is there a correlation? What is the variance? How the data is changing with time? So these are the patterns that machine learning engineers try to extract from your data. Image processing, computer vision are some of the application areas of pattern recognition, and they could be used to develop license plate recognition system. They could be used to propose a voice-based authentication system, or they could use fingerprint analysis. The next area is data mining. So again, we are extracting meaningful information from a large data set. And financial institutions can use this information to their advantage, or social media companies, they could use this information to propose profit-based advertising or marketing campaigns. Then we have artificial intelligence. By now, I think most of you would have heard about Sophia the robot that is based on AI, and it was developed by Hong Kong-based Hanson Robotics and it was activated in 2014 and then launched publicly in 2016 in USA, Austin, Texas. This is the application of a famous application of artificial intelligence. Then we have adaptive control. Adaptive control can be used in the area of robotics or industrial application, industrial automation, optimizing the processes, do not only control the process, but also improve the efficiency using machine learning algorithms. Next, we have intelligent systems. So, intelligent systems are basically technologically advanced systems, machines or systems that perceive and respond to the environment. An example of this is the Amazon personalized shopping application that is based on facial recognition algorithm. So facial recognition algorithm they use, and then they provide personalized shopping to its customers. So here are some of the key areas that are related to machine learning. Then we have some related theories of to machine learning, that is in mathematics and in programming. Some of them we will touch, like Bayes rule, independence, likelihood, and then maybe covariance and covariance matrix. And since I've heard you have already studied linear algebra, you would have studied matrices and their inverses, how they're used. Then we have eigenvalues, eigenvectors. They perform the linear transformations on the data within the matrices. Then we have the singular value decomposition. So your matrix is basically decomposed into component some matrices, and the idea is to extract useful information within the matrix that lie within the original matrix. Then we have optimization. We will be extensively studying gradient descent, so we'll discuss that. However, convex optimization, EM, and quadratic programming we may not touch in this course. Next, we have dynamic programming. So what is dynamic programming? This is basically a mathematical optimization and a computer programming method. And one of the applications that you're familiar with is recursion, or the Fibonacci series, where we consecutively add two numbers. And in machine learning, what you could do in the future would, for example, if you are for some ease of use or data preprocessing, you could be taking a moving average, and then to reverse this moving average, you could use a recursive algorithm as a post-process of your data output. Then we have divide and conquer. So the concept of divide and conquer is that you have a problem and then you divide it into sub-problems in order to reduce the complexity. For example, merge sort or binary sort are some example of divide and conquer algorithms. If we were to consider linear programming, linear sort, and we have a book of 1000 pages, and we have to find something on page 548. So we will have to go through page 0 to 1, then 1 to 2, and so forth until we reach page 548. So this is a lot of waste of resources and highly computationally complex. So we come up with better algorithms that are merge sort, or the binary sort algorithm. I will give you a brief explanation of the merge sort. For example, we have a problem of sorting this. So what we do in merge sort, we divide it into two equal components. In the first iteration, we have 1497, and we split it into halves until we have only one element. Next iteration. And then we sort these and combine. So this does not require any sorting, but this of course does. And then finally, these two are combined and sorted. We will have 1, 4, 7, and 9. In the next iteration, algorithm solves this part where we have 6, 15, 2, 21. Split it into half, 1 by n, 2, 21, 6, and 15. And then 615, and then 221. Oh, okay, I lost it. Anyways, when we come to a point where we have 1497 over here, and we would have sorted and then combination 2, 6, 15 and 21 over here, and then in the final stage we combine all of them so that all the data is sorted in 9, 15 and 21. So the complexity of this merge sort algorithm comes out to be, in terms of big O notation, log of n. So this complexity is smaller than your linear sort. Therefore, we need to find those algorithms which are less computationally complex, or they are within a feasible range. So we find the complexity and we address the complexity in terms of time and space. We need to consider both of them when we are designing an algorithm. The input to our programming model, machine learning model, should be within a feasible range. It should not be set that complex such that the solution becomes infeasible, takes a lot of time or too much space. So next comes the different type of machine learning algorithms. Here we are going to discuss 6 of them. So machine learning algorithms can be used to solve different kind of problems. For example, classification. Then we have regression type problems, clustering, and then dimensionality reduction, strategy learning, and association. There are 6 type of machine learning problems that we are going to try and solve. So for classification, we have a set of label data, and your program should find the boundary between these labels. For example, if we set a linear boundary between these labels, we could say this could be one linear boundary, another one could be this linear boundary with some error margin. Of course, this is the error, and then this could be another linear boundary between the labels. So in this case, a new sample, we call this sample unused sample or unseen data. We have this unseen data and we have to decide its label. This can be solved by a classification algorithm. Here I have given one example of heart disease prediction or classification. Problem where we have a data set. This is the data set which has 15 examples, and each row is one data sample. And each data sample will have certain values, we call the column names. gender, age, cholesterol, heredity, smoking, intake, activity, diabetes. There are 12 total features. We call them features of the input X. And then we assign a label. Either that person who has these characteristics, he has the disease or not. So if he has, it is yes, otherwise no. What you notice over here is that all this data, it is categorical, means it is categorized with certain inputs, such as gender can be either male or it could be female. Cholesterol could be low, medium or high. Then smoking could be yes and no. They are defined in categories. So for a machine learning algorithm to work, generally it is better to convert your data into another format, another representation that is categorical to numerical. So we have the numerical data. We convert this first row into numerical data. So for gender, we say if it is male, then it is 1, otherwise it is 0 for female. So first data sample has a female, so we say 0. For the first sample, we have 0. Leave the age right now. And then we have cholesterol, low, medium, high. So we assign 1, 2, and 3 as an example. It could be something else you could use. Because the cholesterol is high, we replace it with 3. And this is how we complete the data set. Convert your categorical data into numerical data. And then we see, why did I leave this? So for age in our country, it could, let's suppose, be up to 85. So we could either assign 1, 2, 3, 4, whatever, which is already 35. But one other option could be the people who are in the range of this age, they could be assigned 3. So we assign 3, who is this female, this age of 35. And between 65 and 70, we assign 7 as here. So we can also define ranges for our data. All this will be part of pre-processing. So the input features are transformed, categorical data is transformed into numerical data. And for the label, again, we have yes, no. So if it is yes, as in this case, we assign 1. And in the second example, we have 0. So y1 is 0 and y0 is 1. So now if a new example comes, for example 16, a new patient comes, you have all the historical information, you have the data set, you have trained your, for example, machine learning algorithm, and your model is now trained. So this new X15 new example we have to decide what would be the label. Either it will be 1 or it will be 0. So it is trained, this algorithm is trained. We give the X input and it will predict. We have a machine learning model here. We give the new sample, the X15. And it will determine y either 0 or 1, depending on how the model is trained with this. So this is a classification problem or a prediction problem. And then we have, so for this example, if we take these red dots to be no and then black to be yes. For this decision boundary, we will classify this sample as not having the disease, and thankfully so. Next, we have the regression type problems. Again, for regression, we have a pair, a set of x and y's. So on the x-axis, for example, we have land area times 10 meter square, and on this axis we have the price per meter square. Prices are high, so we say multiples of 100. So now, your program should be able to find the functional relationship between y and x. So if we need to find the relationship, we need to find this function. So if we are given an x, that is a new example, it should be able to give us the value of y. For a given x, it should give a value of y. Right now, all these points, they are part of the data set. We know the value at 25, 30, 35. So we have trained this function already. And at this point, we know the value is, for example, 600 and 400K. And this value has 65, 650 and 380K. Now a new client comes and he says, what about x dash, which is not 60, not 65, but 625. So what will be the value of y now? What will the price of this land? 625 meter square. So the value lies between these two. And or for example, the pattern that is learned by our data set is this. So we know the value at this point and at this point. And we can use this value, for example, so the pattern is this. The learned pattern is this. So we know this value and we know this value. The solution, the 625 meter square value of x lies, or x dash lies between these two. We call this, if in terms of, we could solve this by interpolation. Find a point between the known 2 points. Or if we want to solve a problem at, let's suppose, 800 meter square, which is not known and it is outside the boundary of the given data set. We have no value at 80. 800 meters square. So we could extrapolate our data and find the value of y for 800 meters square x dash. So that we call extrapolation. So in regression, we know x and y, so we know this is labeled data. Next comes clustering. So in clustering, we are given unlabeled data. In regression and classification problems, we have labeled data, but in clustering, we are given unlabeled data, and the program should group the data and find the structure of the data. For example, this is our data. On the x-axis, we have the income, annual income, and on the y-axis, we have the debt. We have to group the similar data. For example, initial grouping by some machine learning algorithm comes out to be this. And now we have an unknown data, unseen data sample. Which group does this point or new data sample belongs to? For this, we could use k nearest neighbor algorithm from clustering. In k nearest neighbor, we need to know all these data points within the data set, and we calculate the distance. For example, Euclidean distance x minus x1, y minus y1. And for all these data points, point 1, point 2, we calculate the distance. For example, it comes out 4, 3, 6, and so forth. So we need to store all of these data points within our data set. And then in the next step, what KNN does it? So k nearest neighbor means that we already have this clustering. So we find the closest, for example, if we are considering, it is usually 3, 5, 7, a multiple of how many neighbors we are considering, multiple of odd numbers like 3, 5, or 7, either one of them. So we select, for example, 3 nearest neighbor. These are the 3 nearest neighbor. We have essentially calculated distances with all the points, but these are the closest one. We check which cluster does this data point is closest to. And we can see there are 2 data points which are closer within the cluster 3. So now our new data point will be a part of the new cluster 3-1. So now this data point is a part of cluster 3-1. So this is the k nearest neighbor algorithm. Next come dimensionality reduction. Sometimes our data set has a lot of dimensions. Previously, heart disease data set had 12 dimensions, but it can be possible that we have a data set which has 200 dimensions. There's a lot of dimensions for your data, input data. Or data could be represented as 2D. So this becomes this unlabeled data. This is unlabeled data is given, and then we have the high dimensions. So our program should reduce the dimension of the data by minimizing the loss of information. So the target is to find a lower dimension. Why? To reduce the complexity of your algorithm so it performs better, plus also extract the meaningful information within the data. So dimensionality reduction can either be transitioning from higher space to low space, from 2D to 1D representation, or it could be reducing, selecting the features Among all the features, we find those features that are most important, and we call this feature selection. This is also one way to reduce your dimension. Here in this example, we find a projection line which projects the direction of your data, and then we project all these points from 2D onto 1D. So your data appears to be like this. We can use principal component analysis for this algorithm. I hope we will touch this algorithm. And then we remove the other axis, and we are only left with one axis. So your data is now transformed from 2D to 1D, which has definitely lower dimensions as compared to your 2D. The next is type of machine learning problem that we can solve is strategy learning. A game is given, but we don't know if we will win or not. You may know only at the end of the game. So we now have to design a program so that it learns to win. An example is Tesla, self-driving car, one of the examples. So the algorithm that we can use for this strategy learning is reinforcement learning. This is a game, and reinforcement learning considers the concept of rewards. So if in this example, if this is your destination, if the car is going at the front, we will assign +2, but if it is going on the right, we will assign +1, +1, but if it is going towards the obstacle, we will assign -1 or 0. So what we are doing is we are, for good behavior, assigning a positive reward, and for bad behavior, we are assigning a negative reward. So essentially your data algorithm moves from one state to the next, and it learns state 1, state 2, and the algorithm learns from the environment by using the concept of reward. Again, we don't previously know the data, and data is created at each state, and it may be different from the data in the previous state. Next, we have associations, and we are given a set of items. It is again unlabeled. These are set of items, and program should find items which appear together. In this example, we can see beef and cheese. They appear, combination of beef and cheese appear 3 times in the data set, and chicken and milk appear 4 times in your data set. So we are extracting this information from within the data to find this relationship, and if for a new instance, we would have to define which items could appear together. So these are the 6 types of machine learning problems. First is classification, then we have regression, clustering, dimensionality reduction, strategy learning, and association. Now we come up with the types of machine learning methods. The supervised learning, then we have unsupervised learning, we have reinforcement learning, and semi-supervised learning. So for supervised learning, all the data are labeled. Example, classification, and regression. For unsupervised learning, we do not label the data. Clustering, dimensionality reduction, and associations are examples. Then we have reinforcement learning, and reward is given to your behavior, as I told you in the previous slide. An example is strategy learning. Now comes the semi-supervised learning. So some data may be labeled and some data may not be labeled. So we can use examples. Some examples are classification and then clustering. Another way of types of machine learning categorizing them is parametric, non-parametric, and semi-parametric algorithms. So parametric models are global models. They are used to describe the data. Then we have non-parametric models, and the global data is given. An example of this is regression, where we know the model and your program estimates the parameters of the global model and answers based on the found model. And for non-parametric model, there is no model. So your program keeps all the data, as in the case of k nearest neighbor I discussed with you, and answers based on them. So all the data must be stored, and those data points are then used to answer the new query. If query is given, your program finds the smallest number of closest data instances and answer by combining those. We call this lazy, also known as lazy or memory-based, case-based learning. Then comes your semi-parametric modeling. A small number of local models are used to describe the data. For this, we may not be studying this algorithm, but we have the Gaussian mixture models. So we assume that our data has a known distribution, structure of your data, how it's present. And this is a local model. So your program estimates the parameter of the local model and answer based on the found model. So if a new example comes, the local model is updated in this case. So we have GMM for this semi-parametric. For parametric, we have the regression example. And for non-parametric, we have the example of k nearest neighbor. Then the type of learning is ordinary learning, that is non-meta learning, that we learn from the data, the patterns within the data, the relationships between the data, features. And then we have the meta learning. Instead of learning from the data, we are teaching the algorithm to learn how to learn. Examples are bagging, boosting, inductive transfer. And I would like to touch these topics within our contents. For example, we have a learned model, trained model, and we have to design a new model. So instead of training it from the scratch, from initialization, what we do is we extract or transfer characteristics from this model onto the new model. So this model does not have to start from the scratch. It transfers the knowledge from an already existing model. We call this transfer learning. This winds up the lecture contents for today. So essentially, what we studied was what is machine learning, then the application areas, some of the related disciplines, and then some of the related theories to machine learning, then type of problems that machine learning can be used to solve, clustering, classification, regression, dimensionality reduction. We have two types in this. Either we reduce the dimension from high dimension to low dimension, or we use the feature selection method. Then we have strategy learning, and which has the concept of reward and reinforcement learning. And then we have the associations within the data. We're trying to find the relationships and types of learning models, then learning methods. And finally, we conclude our presentation for today. If you have any questions, you could ask me via my contact. Thank you for listening to me.